Good morning, everybody. Thanks for joining. I see a couple of folks getting in here. We have a great crowd joining us today for this webinar, and I'm going to give them a minute or so to get in. So thank you, and stand by. Okay, looks like we're going to get started. Thank you very much, everybody, for being patient. Looks like we have a nice crowd joining us, and thanks for attending this session. My name is Philip, and I'm responsible for strategy and business development at Bardess, and I'm joined by Serena, our lead data scientist. Today we're going to be talking about creating a forecast. Specifically, we're going to compare two different approaches. We're going to compare what it takes to build a forecast by hand versus what is now available from TangentWorks, which offers a unique model generation technology that provides you with your best option to build a time series forecast. I ask that you keep your questions to the end, and we're going to have some time at the end to answer them. And thank you, and enjoy. So what is a forecast? It's a technique to predict events through a sequence of time. It is time series forecasting in general is something of a dark horse in the field of data science. Although it's one of the most applied data science techniques in business, used extensively in finance, in supply chain management, production, and inventory planning, and has a well-established theoretical grounding in statistics and dynamic systems theory, it retains something of an outsider status compared to more recent and more popular machine learning topics such as regression, classification, or natural language processing. At the crux of this disconnect is that time series forecasting can be cast as a supervised learning problem, and hence the entire arsenal of machine learning methods can be thrown at it. But at the same time series forecasting problems have several unique quirks and idiosyncrasies that set them apart from typical approaches to supervised learning problems. This requires data scientists to rethink their approaches to building and evaluating models. We're going to look at an example today in the demo. I'm sure many of you are familiar with bike sharing programs that exist in many cities around the world. And we need to predict the demand for bikes across several locations in a large metropolitan city, Washington, D.C. in this case. How do you go about forecasting how many bikes you need at each location? And we have some historical data, and as you can see, the demand varies greatly from day to day, hour to hour, but is generally trending up over time. There's also some seasonality evident. More demand in the summer months, for example. This makes sense. But what other factors do you think might influence the demand for the bikes in this scenario? What about the weather? I'm sure a thunderstorm will impact demand. What about the time of day, temperature and humidity? These factors are called features by data scientists, and we need to create a multivariate forecast that take these features into account when generating a forecast. So what are your options? You could try building what we call a handcrafted model using R or Python. And using libraries like XGBoost and TensorFlow, and in this case Facebook, profit algorithm, as the name suggests, all the work is coded manually, and you need to be an expert to do this well. Notice that the model building process is recursive. It takes several iterations before it can be deployed to be useful. You could also use one of the popular AutoML options like DataRobot, RapidMiner, H2O, DataIQ. These solutions do a great job at automating the engineering steps. But notice that this brute force method is also iterative and is designed to find the best algorithm. There is also a key step that is very difficult, which is the feature engineering step. Some of this is automated, but most of this is still manual. Finally, we have Instant ML, which is unique to TangentWorks, which we are introducing today. Instant ML is a new category of model generating options on the market. TangentWorks, or TIM, stands for Tangent Information Modeler, takes a completely different approach. And instead of trying to find the right algorithm, it determines which factors or features in the data are important. This is a game changer. TIM can produce a more accurate time series forecast in seconds is very easy to use and integrates with many other tools. You can use it right inside of Excel, your favorite analytics platform, but it also scales to support big data platforms like Hadoop. An interesting side effect is that to build a forecast, Tim finds the most predictive features in your data. Sometimes, depending on your use case, the features themselves can be more important than the forecast that you're trying to generate. Because if the features change, it tells you something in your business has changed. This is the anomaly detection feature provided by Tim. So what we're going to do today is we're going to compare a handcrafted model on the left with instant ML or real-time instant ML from TangentWorks. We're also going to take a shortcut. Instead of developing and selecting the model as part of the process, which would be needed to be done with handcrafted models, we're going to predetermine that model selection and use the profit model as our input. Of course, in a real world, a data scientist would be doing this across multiple models in order to determine which model performed better. So in this case, it's profit from Facebook versus TangentWorks' Tim, and we look forward to the demo in a second or two. But before we get there, I just want to say a few words about TangentWorks. It was named one of the top 10 most innovative machine learning companies in 2019. It's a fast, automatic, scalable, and easy to deploy forecasting and anomaly detection solution. I said what makes it unique is that it works by finding the right features, not necessarily by finding the right algorithm by brute force. It can be deployed on the cloud, on-prem, as a web service, or on the edge. In fact, the algorithm is so lightweight that we have several customers in Europe using it on edge devices. It's already integrated with Excel, Power BI, Azure's AI, machine learning, and Data Factory and their IoT platform, as well as several of your popular analytics platforms like Qlik, Tableau, and Alteryx, as well as Siemens's MindSphere IoT gateway. It's priced so that it's based on the consumption of the forecast, not how that model is consumed. So whether you consume it in Excel or Qlik or use it in a pipeline for a big data project, you pay for the consumption of the model. The actual method of consumption is immaterial. Licensing options start at $2,000 a month, go up to $10,000 a month for enterprise use. And of course, right now, a free trial is available, and I'll let you have that information at the end of this webinar. I encourage you all to take advantage of that. So let's get on to the demo. Serena's standing by, and she's eager to show you. And what she's going to show you, she's going to show you the steps that are required to create a time series forecast using Facebook's profit algorithm. And I want to contrast that with the single step that we're going to use to create a time series forecast using Tim. At the end of that, we're going to be comparing the two for both effort and accuracy, and I hope that you enjoy the webinar. Thank you very much, Serena. I know you're eager to get started. I hand the ball over to you.
Thanks, Philip. I'm going to go ahead and share my screen. Okay, what I have here is the data set that we're using in Excel. I want to show first what type of data we're working with and explain what a time series is. I often find that forecasting is a word that many people are familiar with, but there's sometimes a bit of confusion about what kind of data we're talking about when we're talking about time series. So we're looking at sequence of data points that are taken at successive and equally spaced points in time. So what we're looking for a column with a timestamp. In this case, we have data for a bike sharing service in Washington, D.C. between January 2011 and August 2011, and the data is taken at regular hourly intervals. So we're starting at midnight on the 1st of January and going 1 hour at a time. The variable we're most interested in is CNT. This is the count of registered users at that time, so how many people were using bikes. And this is our target, which is what in statistics we also call response, or the dependent variable. And this is the number that we're trying to predict in the future. We also have some other columns. These are the ones that we call features in machine learning or predictors in stats. I tend to switch between one and the other as synonyms, so hopefully that's not too confusing. And this is the information that can be useful for predicting the target variable. What we have here is some weather data. We have wind speed, humidity, and the actual temperature and the feels like temperature. And then we have a binary variable that takes value 1 when the day is a holiday, and it's 0 otherwise. So the task that the problem we're trying to solve is predicting the demand for bikes for the next 24 hours and for the next week. And we're going to want to compare the process speed and accuracy for both the Facebook Prophet library and team. So I'm going to jump into a Python notebook here and show how we do this prediction in Prophet. Prophet is a forecasting procedure developed by Facebook, and that is implemented in both R and Python, and it provides an automated forecast that can be also tuned manually by analysts or data scientists. So what I'm doing here is I want to show a typical workflow to produce a forecasting Prophet. So we're going to go ahead and load the libraries that we need. I'm loading Prophet. I'm loading some other pretty standard libraries for data science in Python. I'm using pandas and scikit-learn, and then some plotting. I'm going to go ahead and load the bike sharing data. We're going to look at, and so we can see we have the timestamp, the count, and all the features. One thing we would do at this point is we'd want to visualize the data. Here's a plot of what we have, and we can zoom in and see that we have some regularities here. What we see here is these are likely during so weekdays or work days where we have a couple of peaks around 8 a.m. and 5 p.m., which are probably like commuting times. And then we have this other shapes here on the weekend where the peaks are a little later in the day, when people are probably going out for brunch or whatever else it is they're getting up to on the weekend. So next I want to go a little, show a heat map of the number of bikes that are in use at any point in time. And so the darker areas will show the times where there are less bikes in use, and the lighter colors indicate the times when there are more bikes, more users registered. And so we can see again that the pics, the lighter areas are in correspondence of the earlier times during the weekdays or the 5-6 p.m. slot, and then we have some lighter areas as well on the weekend in the middle of the day. So if we were doing, to use Profit, we have to process the data and put it in a format that is accepted by the model. Profit expects as input a data frame, a pandas data frame that has 2 columns or more. But the 2 columns that we need are one that is called DS, and it has to be a date type, and then a Y to indicate the target. So we're going to take the data set that we already have, and rename it to call timestamp DS and CNT as Y. The other thing we need to do for Profit, if we want to, we can't pass the holidays as a but it has to be in its own data frame. So again, it expects a data frame that has a column named DS for the date and the column named holiday with the name of the holiday. So we're going to transform our original column into that. I actually don't have the names of the holidays, and it doesn't really matter to Profit. That's more for us. So at this point, we can go ahead and prepare for forecasting. Like I said before, we're going to try and forecast first 1 day ahead and then a whole week, and see what the results are in terms of accuracy. So the first thing I'm going to do is I'm going to split the original training set into the original data set into a training set and a test set. And I'm going to do so. The last day that we have is the 11th of August. So I'm going to include in the training set everything up until the 10th of August, and then leave the last day for testing. And I'm just going to show that the last interval we're looking at is the 9th at 11 p.m. and then we'll start again on the 10th. The next thing is we're going to initialize the Profit. We're just going to pass holidays. All we need to do at this time is just passing holidays, the data frame for holidays as a parameter. And then we're going to add regressors for wind speed, humidity, and temperature, the 2 temperatures, which are the predictors we're trying to use. And then we're going to fit the model. At this point, we're going to take the test set and forecast. Again, Profit expects as input a data frame even for the prediction, so we're just passing the dates really, and then we're going to what it does is it returns an estimate. So like y hat represents the prediction. We have upper and lower bound, and then we have some other all the components of the model are estimated here, and there's quite a few for each of the predictors and for the holidays, and then for some weekly and daily seasonality. And this is what the prediction looks like. Y here represents the true value of the predictor or the target, and then we have y hat is our the profit prediction. So you can see it's sort of following the shape of the curve of the true value, but it doesn't quite get the picks both at the top and the sort of like the ones that are lower. So we'll calculate the mean absolute error, and we get 69, roughly 69. This is a measure of the difference between the true value of the target and the predicted one. So next we're going to do the same for a week ahead. and again, splitting the tests into train and test set. And this time we're going to stop at the 4th of August. Again, we're going to initialize another model passing the holidays, and then we're going to add the regressors and fit the model. And if we look at the forecast, once again, we can see that we have the blue is again, the blue line is again the predicted value by the model. And again, we are following the shape, but we're still missing the picks, and we can see that the shape on the weekend as well is sort of like very similar to the one that it predicts for the weekdays, and then it completely misses the peak for the 1 p.m. or 2 p.m., whatever that is. So going to calculate the error for this model as well. I think this is a little lower compared to just before, but around the same. So this time, we're going to try and tweak a little bit the parameters. So we're going to do some tuning, and this is what a data scientist would do on a regular basis. The parameters we're going to look at are the seasonality mode. We can choose additive or multiplicative, and additive is the default. So we're going to try the alternative. And then we have yearly, weekly, and daily seasonality. This is from the profit documentation, so we can, so far we're left it on automatic. What we're going to do now is we're going to try and set a number for the Fourier terms to generate. Fourier transforms are used to model the seasonality in the model. And so the more terms we add, the more precise it's going to be. So I'm going to run this loop. This is going to take a little while to run, so I'm going to take I'll take this time to explain what we're doing. We're essentially looping through two different numbers. We've set the yearly seasonality to false. Our data doesn't actually cover the entire year, so we don't need to worry about that. We do, and we've seen what we've seen in the picture in the plots, that we do see some weekly regularity and some daily regularity as well. So these are the ones that we're most interested in. And so we just loop through a series, like a few different values from 2 to 14. We just try. We essentially, for each combination of them, we'll calculate the mean absolute error and compare. What we want is we want to minimize the error for the forecast, and so that will tell us what are the optimal parameters. So each time we're fitting a model on the training set, and then producing a forecast and saving the value for the mean absolute error. And then the weekly and daily seasonality that we have, parameters that we have used. It's going to run for a little longer. This is typically what we would do in a model training setting. Here we go. So here's what we get in terms of the colors. So in terms of error, the numbers on the axis are the weekly. So the weekly seasonality on this side, and the daily seasonality on at the bottom. So again, darker blue colors represent lower values for the error, and lighter colors are higher values. So we want to be somewhere around here, where we have more terms both for the weekly and the daily seasonality. The minimum value that we can get is for a 14 Fourier terms in the weekly and 11 for the daily. So we're going to go ahead and fit the model again with this values. And if we look at the forecast, the forecasted values on a plot, we can see again why the green line this time is the true value, and then we had the blue line is the model we had, the first model we fit, and then the second, the y hat D2 represents the most recent one with the tuned parameters. And we can see that this time the line follow each other a little better. It's getting the picks a little better, but it's still kind of far from the actual from the true value of the target variable. Next, we'll do this for the week ahead. This time I've run this loop before, so I'm just going to show the pictures once again. We are not fitting for the yearly seasonality. We're trying for weekly and daily, different values for weekly and daily seasonality. And when we put that on a plot, we can see that the mean absolute error again is lower when we get to higher values of the seasonality parameters. And the best value, the best error, the lowest error we get for weekly and daily equals to 14. So we fit that model again, and looking at the prediction, this might take a little longer. Okay, good. Looking at the prediction again, we can see a little better fit. The green value is again the true value, and then we have in red the value for the last model that we fit. Okay, so we see that we have improved it's possible to improve the prediction by doing some parameter tuning, which does require a little bit of time in terms of running the for loops and trying different parameters. So going into Team now. Team is a predictive modeling engine that automates feature engineering and model building for time series forecasting. So the first thing I want to show is going into our datasets. I've already loaded datasets, and we have this nice screen, so we can look at the time series plot here, and we can look at we can turn on and off several variables, see how they behave over time. The first thing I want to show is instant ML. So if I go into the forecasting tab, I want to show how we can produce really fast predictions. So I'm going to take the daily data first and click on this icon here. This is for producing instant forecasts. So we're going to take on day and predict 1 day ahead, and there's no other parameter. There's no need for setting any parameter. We'll just add a forecast, and it's really fast. It builds really quickly, and we're going to click on it. We have this. We can see that already. This forecast looks like it's following the sort of like, it has a very reasonable shape. Seems like it's following the patterns was in the previous data. We're going to do the same for the weekly. Same, instead of setting it to 7, instead of setting it to 1, we'd set to 7 and add a forecast. And then we're going to go and see what that looks like on the plot. So again, there's no need to set any parameter. The team engine automatically takes the data available to build the model and produces a forecast for the 7 days after. And again, we can see that it's following the shape the previous of the previous historical data, and we can see that we can also see already the weekends behaving slightly different from the weekdays. Alternatively, it's also possible to build model from scratch and have a little bit more control. The way you do it is you go into the model building definition tab. We'll add a new definition and we'll call it comparison wick 2. We'll pick the bike sharing dataset. So here it's possible to decide a bunch of parameters in terms of what days we want to forecast, what time we want the forecast to be done. In this case, we'll just let this at each day at 8:20 we'll get a forecast for the day ahead. We'll click to the next, and we'll have here we can select which predictors we want to use, and again, it's possible to change when the updates for the data are coming. We're going to leave the offset to 1 day. We're going to assume that we have forecasts for the day ahead, and we'll do that for all of the parameters. Next, we can choose to use we can choose what data to use. We could choose to exclude certain certain dates, or maybe start from a different point. And then in the last screen, we can see there's a lot of different parameters that you could play with and sort of try different configurations. We're going to leave everything as is and finalize the model. Once that's done, we'll click on build, and we'll see this is also pretty fast. The way Team works is it finds the most important features, both in terms of transformations and interactions, and we'll see a second what I mean. So we click on this little icon, we can see again a plot of the time series of the historical data with compared to the forecast and the residual down here, so the difference between the true value and the predicted value. What's really interesting here is this tree map, which allows to see what features were created and what's their importance, like how relevant they are to the prediction. So in time series forecasting, you often don't just use the input features as they are, but you actually do a series of transformation and you want to look at interactions between them. So for example, here we have a moving average with a certain lag over a window of 30, and then we have all the interactions of various predictions. It could be the target variable with predictors, or predictors interacting with each other. The holidays, we have the holidays here. So this makes it so Team does this automatically and uses borrows from the field of information geometry to find the best set of features and transform. And it does so building several models with different sets of features for each time of the day. So this would be the model for midnight, and then as the interactions with between features change, it also adjusts it also adjusts for that change and produces a different set of feature depending on the time of the day. So once we build a model, we can go back into forecasting, and this time we'll create a new prediction. We'll select the model that we just built, and the week here, the data here stopped at August 4th. So we'll do that. We'll select that as a starting date for the prediction, and we'll say we want to predict 168 intervals ahead, which is a week. We'll go ahead and create a forecast. It'll take a second to get the actual prediction. And if we click on this, I want to deselect this. So we get the forecast for the week ahead. And we can do the same with the daily, with the day ahead. I've already done this, and I've exported the results so we can compare them to profit. So going back into loading the data, here's the prediction for the day ahead. What we have here is the blue line is our true value, and then we have the first our best profit model, so the second one with it, and then I've loaded the forecast for the day, done both with the instant ML method and the building the model from scratch in Team. So we can see how Team gets a little bit more accuracy, both on the instant ML and the model, the second model we built. And if we compare the mean absolute error, we'll see there's a significant difference between profit and Team, both when we use the instant ML, so we do no parameter setting at all, and when we build a model, setting a bit more, tuning a bit more parameters. Similarly, for the week ahead, we have, again, I want to zoom in a little bit to show how Team is following the shape of the original value, the original curve, a little better, while profit seems to be sort of following the same cycle, the same seasonalities for the weekday and the weekend at the same time. We can see the accuracy for Team is much higher. And again, looking at the actual mean absolute error, there's a significant difference between the profit prediction and the Team prediction. So some key takeaways for this. Both Team and Profit offer automated solutions and a way to build automated models for time series forecasting. I think the main difference here is Team has this really nice interface where you don't need to do any coding, and it's sort of like set up for doing everything in the UI, but also everything that is done that I've done here in the UI is also available via the API, and so that allows to create more automated and embed the prediction into any type of code or production system you might have. I I think that concludes the demo, and so I'm gonna hand it over to Philip for like wrapping it up.
Okay, thank you very much, Serena. Fantastic demo. Thank you very much. And looks like we got quite a few questions coming in here. Let's have a quick look. It looks like I got the first question here. It says, where has TIM been deployed in production? And do you have any benchmark data? Now, that's a great question. Thank you very much for asking that question. Let's start with the benchmark data. TIM has won several data science competitions in the past, including IEEE, GEFCOM, and TEPCO, where several hundred data scientists competed. And Tim was a winner at those contests. In fact, during those contests, data scientists worked for many months to produce the work for those contests, and Tim is able to do that in minutes or seconds. So those not only was it benchmarked against other existing technologies as well, so we can provide some benchmarks against Ultrix and against Microsoft Azure AI tools and show you the speed and accuracy there too. I'm also going to talk about, you asked where it would be deployed in where it has been deployed in production, and I can answer that there's been several large deployments that are live right now, mostly in Europe, however. One of those companies is BASF, for example, and then several electric utility companies are using it as well, including one using it on an edge device on smart meters. So speaking to that IoT use case. So thank you very much for that question. And Serena, you have a question in your inbox there. Do you mind reading the question and taking it away?
I do. My first question, can Profit be used in a UI? So Profit is distributed and deployed as a library in R and Python. So it can be used within both those environments. It's easy to install as a GitHub repository. However, it does not come with a UI by default. So you'd have to sort of build your own, and then on top of either the Python or the R distribution.
Oh, excellent. Okay, excellent. And you also have another, looks like another question there. Go for it.
I can take another one. This one is on Team. Why does Team fit multiple models? So we've seen how when we build a model, we get several tree maps. Those are a combination of features, each of them for a specific model at a specific time. What happens is Team finds the best set of features for a given interval of time. And it does so because the interaction between features can change over time. And so the best way to improve accuracy of the prediction is to just fit several models depending on the time frame. And a good example is what we saw with the data where we had some peak times during the weekday. Also, so during work days, we had specific peak times. So it's a lot easier to get an accurate prediction for the specific time of day, say like the 1 p.m. For the weekend, for example, versus the night, or even the weekday versus the weekend. And so it makes more sense to adapt the model, to build several models for each of them. And so we get 24 over a day with Team.
Excellent, excellent. Thank you. That's great. Yeah. So Tim actually builds 24 models instead of just one in order to make sure that that accuracy is there.
Yeah, because each time of the day will have a specific set of feature that makes gives a more accurate prediction.
Exactly. And Tim did this on its own, right? You didn't have to say do it by interval. It was all automatic.
Yeah, that's out of the box. It finds the regularities and builds the models based on that.
Excellent. And I have another question here for you, Serena. Can you talk to us a little bit about anomaly detection?
Sure. Team also has an option for anomaly detection. What we mean by anomaly detection is identifying data points and observations that are odd and anomalous. So In the context of time series analysis, that can be done by comparing the prediction to the real value. And so when the distance between a prediction and the real value is over a certain threshold, we can flag that data point as an anomaly. And that is also a functionality that team has out of the box, where you can select a certain, you can decide the sensitivity of the model. So you can choose to look at historical data and maybe say the 1% of the data points are anomalies. And so the model is built based on that. And then for future predictions, for future data points, the threshold that's been calculated based on the historical data and on the sensitivity, then it will be used to flag new anomalous data points. And then again, that comes out of the box in TIN.
Excellent. And without mentioning the client, you are working on a use case with that right now. Do you mind just describing broadly what the use case is for anomaly detection, for example?
Yeah, anomaly detection makes a lot of sense in the context, for example, of predictive maintenance. So we're working on, in the context of Internet of Things. So we're working with this client that has a lot of telemetry data on a series of machines, and the idea is to look at the history of the sensor, of the data coming from the sensors, and identifying when there's a deterioration in the functionality of the machine. And so that point gets flagged as an anomaly, and then you can send an alert to your mechanics, for example.
Excellent. Thank you very much. And it looks like I have this question. Let's take this as the last question. I'll take this one. It says, how can I get Tim? And that great question. Thank you very much for asking. The best place is to start with a free trial. So on the screen right now, you'll see the URL for the free trial. If you don't have that, feel free to contact me by LinkedIn or by email, and I'll be happy to send that URL to you. And then what will happen is once you click on that and you access the free trial, Daniel or Serena will contact you. We'll work through your use case, help you with any data engineering that needs to be done, and really understand your use case. And then I'll work with them and you to really to size the subscription appropriately for your use case. And just to give you a feel, the free trial allows you to use up to 1,000 to conduct 1,000 forecasts, and then the basic package, which starts at $2,000 a month, allows you to do 2,000 forecasts a month. Right up to the enterprise level, that costs $10,000 a month, as I mentioned earlier, where you can do 30,000 forecasts. So thank you, Serena. You've done a great job. I really appreciate it. And everyone, thank you for attending this webinar. We look forward to seeing you on our next webinar, and have a great day. Bye-bye.
Thanks. Bye.